Welcome, Mrs. Greathouse here. We're working on the second part of Chapter 11, Part 1. You're going to learn how to balance chemical equations. Okay, just like when you make cookie dough truffles or chocolate chip cookies or lasagna, you need a recipe to show you how much of each ingredient to set up those proportions so you get something delicious. Okay, balancing chemical equations in chemistry is the same. It shows us what proportions of what reactants we need to get the proper product. Okay, key point here. When we write our balanced chemical equation, we're going to start with our skeleton equation. Then we're going to use coefficients to balance it so that it obeys the law of conservation of mass. Okay, coefficients are going to be numbers in front of your products and reactants. Okay, so if we imagine making a bicycle as a chemical reaction, we would need one frame, two wheels, one set of handlebars, and two pedals to make that bike. Okay, the coefficients are in front of our formula for our reactants. They can also be on the product side. We show them as a number. If there is no number there, like a lot of things in chemistry, it's assumed that that number is 1. These are our coefficients, whole numbers that are placed in front of the formulas in an equation in order to balance it. Okay, so just like a lot of chemistry procedures, we have steps. Here's steps for balancing chemical equations. There will be 6. Okay, first of all, we need to go back to Chapter 9, remember our nomenclature, and determine the correct formula for all the reactants and products. Then we're going to write the skeleton equation. We start with our basic equation with no coefficients before we balance. Then we're going to look at the reactants and products. Do I have the same number of atoms on each side? When we count these, we are going to count polyatomic ions as a single unit if it appears unchanged on both sides of the equation. So if you have a sulfate, you are going to look at that SO4 2 minus as one sulfate, not a sulfur and 4 oxygens. Okay, steps 4 through 6. Step 4, we're finally going to balance. It's easiest if you start with elements that only appear on each side one time. Start with those, then balance hydrogen and oxygen last. They are usually on in products and reactants more than one time. Never change your subscripts. We need to keep our compounds and molecules their same configuration. We're not going to change any products or reactants. To balance, we always use the coefficients. Okay, then you double check, and I'll show you how I do that. When you start out, you're gonna write right underneath. You're gonna write yourself notes. Keep count down there. Last step, make sure all your coefficients are in the lowest possible whole number ratio. Again, if they're all divisible by 2 or all divisible by 3, you'll need to reduce. Okay, we'll start out super easy. We are going to balance carbon plus oxygen equals carbon dioxide. Okay, remember that oxygen is one of our gases that is found as a diatomic molecule, so it's going to appear as O2. Okay, that will work with any gas that occurs as a diatomic molecule. So remember H plus 7. So we have our carbon plus our oxygen yields carbon dioxide. Okay, what I do is right under my arrow, I start making a list of what I have and how many I have. So on the left, I have 1 carbon, and on the right, I have 1 carbon. Now I'm going to look at oxygen. On the left, I have 2 atoms of oxygen. On the right, I have 2 atoms of oxygen. Okay, all my numbers are the same on left and right, products and reactants. So it is balanced how it is. In this one, I do not need to add any coefficients. Okay, let's try this one. Hydrogen and oxygen react to form water. The reaction releases enough energy to launch a rocket. Write the balanced equation for the reaction. Okay, I'm going to start with my skeleton equation. H2, because hydrogen is one of our diatomic gases, plus O2 yields water, H2O. That's my skeleton equation. Okay, I'm going to start counting atoms. I'll start with hydrogen. On the left, I have 2 atoms of hydrogen. On the right, I have 2 atoms of hydrogen. My subscript tells me so. Okay, so far so good. Balanced. Don't have to add any subscripts yet. Okay, let's look at oxygen. On the left, I have 2 atoms of oxygen. On the right, I only have 1. Okay, so the oxygen's not balanced. I need to do something about this on the right side. Okay, if I add a 2 coefficient here, this 2 applies to the hydrogen as well as the oxygen, and we do this like distributive property. We're going to multiply. Okay, so now 2 times my oxygen, I'll have 2. Okay, oxygen looks good, but I have to go back and double check. Now on the right side, 2 times 2 for my hydrogen, I have 4 on the right, but on the left, I only have 2. So if I add a 2 coefficient on the left, now 2 times 2 is 4. Now I have 4 hydrogen on the left, 4 hydrogen on the right. Oxygen, I still have 2 of each. So this is my balanced equation. I cannot reduce my coefficients. I have 2 and understood 1 on the oxygen and 2 on the water. They're not all reducible by the same thing. So we're all done with that one. Okay, another example, last one. Write and balance this equation. Calcium hydroxide plus sulfuric acid yields calcium sulfate and water. Okay, we got an acid-base reaction here. Calcium hydroxide. First I'm going to write my skeleton equation. I need to write my formulas. Hydroxide is OH minus. Calcium is Ca2 plus. So I have to remember my crisscross. And calcium hydroxide is going to be CaOH subscript 2 plus sulfuric acid. Remember, ic acids come from 8. I ate something icky. And crisscross H2SO4. Sulfuric acid yields calcium sulfate. So remember, sulfate SO4 2 minus, calcium Ca2 plus, do crisscross, CaSO4 plus water, H2O. Okay, so now I'm going to start counting my atoms. I'm going to start with calcium. Okay, I have 1 on the left, 1 on the right. Next up is my sulfate ion. polyatomic ion. I have one on the left and one on the right. So far, so good. Next up, let's check hydrogen. I have 2 on the left in the calcium hydroxide, and I have 2 more in the sulfuric acid, so a total of 4 on the left. On the right, I have 2 in my H2O. Okay, I need more hydrogen. It's not not balanced. So I need more on my right. I'm gonna put a 2 in front of my water. Okay, now 2 times 2 hydrogens. That gives me 4. Looking good. Let's check the oxygen. Okay, on the left, I have 2 oxygen in my hydroxide. Okay, that subscript applies there. And 4 oxygen in my sulfuric acid for a total of 6. Okay, I'm going to look at my oxygen on the right. I have 4 in my calcium sulfate, and this coefficient applies to that oxygen. So 2 more in the water. 4 plus 2 is 6. Okay, my equation is now balanced. I'm checking through to see if I can reduce the coefficient, make sure they're in the lowest whole number ratio, and they are. So I'm all done. Thanks for flipping, and we'll see you in class tomorrow.